next is it can be applied to all type of qualitative data. Now qualitative data, nominal or ordinal. So nominal data is nothing but the data where the smallest observation are there, and ordinal data or ordinary scaling is nothing but just arrange the observation in the increasing order of the magnitude. Okay, so here also we can say when the non-mathematical person, means medical person, is dealing with the data, then he has to simple rank the data only, rank, and it is easy to give the rank to the data. Okay, and hence due to mindful or fewer assumption, it has greater range of applicability. So hence these are the advantage of the non-parametric test. So with the advantage also there is also a disadvantage of the non-parametric test. Here, while applying non-parametric test, the confidence interval obtained that are too wide. So range of the interval are too wide. So here if I say that any value, the confidence interval is suppose the height of a student, if I say it will be he is studying in the SYBSC level, then the range may be plus or minus 6 or 5.5 suppose. So I will say the confidence interval is 5.5 plus or minus 5. Okay. But if it is too wide, then it's not proper to interpret. So confidence interval obtained are too wide. The next, due to the distribution free technique, often disregard the actual scale of measurement and substitute either ranks or even more gross comparison of relative magnitude. So here let me tell you that here when applying non-parametric test, so when we see the data, then automatically we will give the rank, because the main theory lies with the order statistics. So the actual observation are not taken into consideration. So this is the main drawback of a non-parametric test. The non-parametric procedure throw away the information which we have told, because the actual measurement is been not taken into consideration, only ranks are taken into consideration. So it often provides a waste information and thus less efficient than the standard technique. The next is the distribution tree procedure may sometimes give quite robust picture. Then the next disadvantage is that is designed to test the statistical hypothesis only. So here only test statistic has been applied, but we cannot estimate the parameters. Also, for testing the interaction, or when we want to know the variability between the observation, then automatically we will apply ANOVA. But here ANOVA means analysis of variance can be applied only under the condition here some assumptions are to be made with the additive model. So these are nothing but the advantage and the disadvantage of the non-parametric test. Now, who are using such type of non-parametric test? Main thing, it has been applied to the biostatistician. So here our statistician, where the use or the application of statistic is becoming closer and closer, but this test helps to the biostatistician. So from how? Here, by applying to the biostatistician data, the data are roughly scaled. So for example, in dealing with the clinical data, perhaps the patient can be classified into two categories, that the patient condition is better or unchanged or worse. Okay, so these also we are ranking in the three category: better, unchanged or worse, or perhaps only ranks that is largest, second largest or smallest, etc. So in this way it helps to the biostatistician. Then next use is for a non-normal. Non-normal means the data or the sample selected or the data collected may not follow the property of the normal distribution, or the shape of the distribution is not known, or they are badly skewed, or they are not symmetrical at that time. So for non-normal data, this data is non-parametric in nature or distribution free in nature. So for example, we can say that do we have a random sample, or these samples drawn from a identical population or not. If there are two samples, then if we want to test that both samples are from the same population or not. So for such type of testing, we are applying non-parametric test. So these are use of the non-parametric test. So here I have just given you the introduction of the non-parametric test. Now let us apply, or what are the test procedure and the test applied, or the different types of test and applied in the non-parametrics. So let us see slide one by one. So here I have tried to compare parametric test and the non-parametric test. So here also I have said, or what are the purpose of the test that I have shown here. So here while dealing with the parametric test, we will say that t-test for the independent samples. So t-test for independent samples had been applied, and same procedure for non-parametric test, Mann-Whitney U test or Wilcoxon sum rank test are there. So purpose for this test is to compare two independent samples. Then next comes, while in parametric test, while applying pair t-test, then in non-parametric test we will say the Wilcoxon match pair signed rank test is applied. What it shows? It examines a sets of difference. So both these tests, while parametric we have to apply, in parametric we will apply pair t-test, in non-parametric we will apply Wilcoxon match pair. Then next comes, if we want to know the variability between the observation, then in parametric test we will apply one way analysis of variance, and which is f-test. Similarly in non-parametric test we will apply Kruskal-Wallis analysis of variance by rank. So both of these compares three or more groups. Then next comes the parametric test. In parametric test, if we want to compare two characteristics, Then while applying parametric test, we will apply two-way analysis of variance. In non-parametric test, we will apply Friedman two-way analysis of variance. Both of these compares groups classified by two different factors or characteristics. Suppose if we want to know relation between two variable, then in parametric test we will apply Pearson correlation coefficient, and in non-parametric test we will apply Spearman rank correlation coefficient. So purpose of this test is to assess the linear association between variable. So here comes all. I have tried to compare the different test of non-parametric and the parametric test. So here also types of test, non-parametric test are there. So types of non-parametric test are sign pair test, sign pair data, or one sample sign test. Then next test is one sample run test, and in one sample run test Wald-Wolfowitz Run Test is there. Then median test for two independent sample, rank sum test is there. Then also Spearman rank correlation test is there. Then Wilcoxon sign rank test. So these are all different tests which have been applied in non-parametric test. Also Kolmogorov-Smirnov test is there. Then Kendall's test for concordance. Also Mann-Whitney U test or rank sum test, or Kruskal-Wallis test. So each test have its own the beauty, so that we will discuss one by one. So here similarly, if we want to know correlation in parametric test, we will automatically apply correlation coefficient or Karl Pearson correlation coefficient. Similarly, for if we want to know if the samples are large, and if we want to apply the test for the single mean, automatically Z test will be there. If the samples are not small, and if we want to know or to test the average or the mean, single mean, then automatically test for single mean are there, etc., etc. These are tests related to the parametric test. Similarly, here non-parametric tests are there. So here next comes, now we will take the test one by one. So first is one sample sign test. So here only this name only tells us one sample, only one samples are taken into here sign is taken into granted. The main purpose here is sign is taken into consideration. So positive sign and negative sign. So how it works? Let us start with a test. So consider the situation where it is desired to compare two things or material under various sets of conditions. The only assumption here are the measurement are such that the deviation di equal to xi minus 1, I equal to 1 to n can be expressed in the terms of positive or the negative sign. So here the sign are taken into consideration. So data or the whatever data is that, so here we have to if two samples are there, xi and yi, here we have to take the deviation. Then second assumption is variables have continuous distribution. Okay. Third is the DIs, the deviation taken should be independent. So here the test, let us start with the test procedure. So let xi comma yi I equal to 1 to up to n be the n pairs of observation from the two population drawn from the two population with the PDF f1 dot and f2 dot. Hence, the hypothesis will be that the probability of x minus y greater than 0 is equal to half and probability of x minus y is less than 0 equal to half. So automatically we will say that the chance of getting positive sign will be 50% and the chance of getting negative sign will be 55%. So our statement or the null hypothesis will be that the chance of getting success and failure are equal. So let us define ui. ui equal to 1 if xi minus 1 is greater than 0 and is equal to 0 if xi minus 1 is less than 0. So here you are knowing that here we have defined the variate ui is 1 if we will get the positive sign and if it is 0 we will get the negative sign. So you automatically let us collect the idea of the distribution. So we will automatically say that ui's follow the binomial variate with parameter p, small p, and p is nothing but the probability of a success, and here p is nothing but the probability of the positive sign, and which is equal to 1 by 2. Now since ui equal to 1 to n are independent and u equal to the total number of positive deviation, hence we can say that for large n, or we can say that for the small samples also we can say that it follows binomial variation or binomial distribution with parameter n and small p equal to 1 by 2. So n is the number of observation and p is equal to 1 by 2 or the probability of positive deviation or positive sign. So let the number of the positive deviation be the k. So success or so in the distribution we are saying let us define x as the number of success. Similarly also here k is the number of the positive deviation. So then we can say that probability of u is less than equal to k and which is equal to summation